some of the rules that we're going to learn are going to help us put together the other rules so that we can find derivatives of more complicated functions. And this is kind of one of those. So it says the derivative of a constant times a function is equal to the constant times the derivative of the function. So a way of thinking of that is if you have a constant out in front of a function, you can just leave that constant alone and then take the derivative of the function. So here's how the proof of that is going to work. Let's call our function g of x, and it's going to be equal to a constant c times our function f of x. And what we want to show is that the derivative g prime of x is equal to c times f prime of x. Okay? So we know that the derivative g prime of x is equal to the limit as h goes to 0 of g of x plus h minus g of x all over h. Okay, so if we do that, g of x plus h is going to be equal to c times f of x plus h. Minus g of x is just c times f of x all over h. Now what we could do in this numerator is factor out the c. So this is equal to the limit as h goes to 0 of c times f of x plus h minus f of x, all of that over h. Now one of our limit rules, if you think back to Unit 1, was that when you have a constant, you can actually pull it outside the limit. So this is equal to c times the limit as h goes to 0 of f of x plus h minus f of x all over h. And this right here is our definition of f prime of x. So this is equal to c times f prime of x. So we've shown exactly what we want to show. Okay, so if you have a constant times a function, you can just kind of leave the constant alone, take the derivative of the function, and then you'll always simplify your answer at the end. So for example here, we have f of x equals 5x squared. Well, this is like the constant 5 times x squared. So f prime of x, we would leave the 5 alone and take the derivative of x squared, which would be, we'd bring down the 2, x, we subtract 1 from the squared, so it would just be x to the first power. So our derivative here would be 10x, okay, which using these rules is obviously much simpler than doing the difference quotient for each function. Another way to think of it whenever you have a number times the power of x, like 5x squared here, you're going to think of multiplying the exponent times the number in front, so 2 times 5 would be 10, and then subtracting 1 from the exponent, so 10x. Okay, the next one here we have g of x equals pi over x to the 7th. Now first I'm going to write this as pi times x to the negative 7. We always want to write it as just a power of x. So using the rule we just talked about, our derivative, we'd multiply negative 7 times pi, which will be negative 7 pi, and then we subtract 1 from the exponent. So negative 7 minus 1 would be negative 8. So writing it in the most kind of proper form would be negative 7 pi over x to the 8th. Okay, and then h of x here we have e times the cube root of x to the 5th. So first I'm going to write this as e x to the 5/3 is how we would write that root. So to find the derivative, we would take the 5/3 times e, so that would be, we can write it as 5/3 times e. And then x, we would subtract 1 from 5/3. So 5/3 minus 1 is the same thing as, this is just kind of off to the side, 5/3 minus 3 over 3. So we get 2/3. Okay, and writing that in most proper form, we have 5/3 e, and then, so the numerator is the power that you put on x, and the denominator is the root that you're taking. So here our derivative would be 5/3 e, the cube root of x squared.